Hi, we're going to answer this question today. It's physics today. This is a bargain B, which is like close to the essay question. So first things first, get a piece of paper, give the definition of impulsive force. Okay, question number 5A. Now, if you, personally the way I memorize this is the word impulse itself is the change in momentum. Okay, so impulsive force is the rate of change, because the formula itself has the time in it. The formula is F equals to mv minus mu divided by t. There's time in this formula, so it is the rate of change of momentum in a collision, or you could also say impact. The textbook gives both answers. Okay, in a short period of time. That is also a piece of key. That is also the keyword here. A short period of time. Okay, not much to learn about the definition. Let's go on to question B. They're asking you to give ways that it can be, the impulsive force can be maximized. Okay, how do we answer a question like this? Again, look at the formula. F equals to mv minus mu divided by t. There are three things that are going to influence the force. The time. Let me get a different color here. The time, the mass, and the velocity. Okay, because v and u both mean velocity. V is the final velocity while u is the initial velocity. So let's talk about the things on the top first, m and v. So first you can say, okay, mass, right? So because F is equivalent to the mass, that means if you have a high mass, you will have a higher impulsive force. So what should we increase the mass of? The baseball bat or the baseball? Well, it should be the bat, right? Because we're using the bat to hit things. So you can say the baseball bat should have a larger mass to increase, or we can follow the question, maximize the impulsive force produced. Okay, I'm not gonna write the full thing. Then talk about the velocity. Should it be swung very quickly or very slowly? You can't imagine it. Here's a piece of bread. This is not advertising. Here's a piece of bread. So if I were to smack this thing very softly, and if I were to smack it fast, the second one would be a lot, would be quote unquote a lot harder to. Would be a lot harder. It would be producing a higher force, thus a higher impulsive force. So you can say the baseball bat should should have a higher or a larger, let's say a larger mass. Wait, sorry, no, velocity. What am I on about? Should have a should be swung. There you go. Should be swung with a should it be higher velocity? Is that how we measure velocity? Hold up. Should be swung with a high. Let's say high velocity or speed for this example. Speed. In order to okay, finally we have time. Time is a little bit different because, as you can see here, time is actually inversely proportional. That means if we increase time, we're actually decreasing the force. Since we don't want that, we want this to increase, we need time to decrease. How do you make time decrease? Give you an example. Let's say they have two eggs here, both dropped at the same 5-meter distance on the floor, except here it's a concrete wall, over here it's a bunch of pillows. These are pillows. Okay, so the pillows will give it a soft landing, thus it's going to bounce. It's going to go slam down and bounce back up, then go back down. Meanwhile, for a hard surface, it's going to hit the floor and not come back up. So you need a hard surface. You need something that's tough. Okay? So when we write the answer, we can say the, let's see, we need it to be tough. So you can say the surface of the baseball bat, oh, you can't see my answer, of the baseball bat should be hard. It's actually kind of weird. I think you could write the baseball bat should have a hard surface. That would be a lot more natural. The baseball bat should have a hard surface in order to, this is where the answer is a bit different, to reduce the time of impact between the baseball bat and the baseball. Okay? Now the final answer, this is where it's not according to the formula anymore, because we've already used all the variables in here. What you can talk about is the other object, because over here we've only been talking about the baseball bat. Now we can talk about the baseball. So this one I took from the answers, so let's just write together, shall we? I'll use the blue pen. So the baseball used should be elastic. So the energy hold up, the energy can be what now? Okay, you know what? Let's just follow the way they wrote it. The baseball bat should elastic to preserve the energy gained before it bounces back. Okay, look on to question C. Okay, we're gonna start with question C because the main part I actually want to solve is this one. So for questions like this, they usually want you to draw a table. So they're giving you a diagram, STUV, and okay, so what we usually do, we're giving aspects. Okay, the word they give us is aspects, and they want the reasons. So I'm gonna write the graph here. Aspects, and reasons. Always follow the question. If they give you like specifications and what is your reasoning, whatever, just follow them. I'm not gonna use a ruler because I'm trying to save time here. Okay, aspects and reasons. And the model we choose, obviously. So first, they want the most suitable, what's this even called? A pendulum? The model of a pendulum, sure. So they give you 4 pieces of information. This one is that they're both single strung and this is double strung, like that. Then they have the information that the tension of the string, the density, and the mass. So what do? Usually with 4 pieces of information, I try to find the one that's the most obvious. So the most obvious, and I try to eliminate the answer from there first. So to me, I think mass is the easiest to understand. So you want to create, right, the pendulum, and the most suitable design, this is a bit vague actually, but the most suitable design is one that will swing the longest, right? Because this whole, swinging business, okay, sorry, I don't know how to draw that. This whole swinging business can go on for longer. Okay, so we are using the effect of inertia here, and we know that through the effect of inertia, the bigger the mass, the bigger the effect of inertia. Thus, when they tell you that the mass of the metal bob is 1.5 kilograms versus 100 grams, well, we're obviously going to pick the one that's heavier. So our answers we can only have answers S, model S or model U. So let's see. What is the difference between these two? They have the same density of frame, the same tension of the string. See? So there's no need to check on those pieces of information. We can only check, do you want it to be single strung or double strung? So what would be the ideal answer here would be the V string. That is because we want to keep the momentum. Why do we say that? It's because if it is a single string, these the metal bobs can actually sway in a lot of different areas, a lot of different directions. But if it is what do you call it, a V-shaped string like that, you keep it, it's more stable, it is a lot more balanced. And according to the official answers of this book, it is so that you can keep the momentum to be in one single direction. Okay, so let's figure out how we will write the answer, shall we? The aspects, we're gonna write the points that you've given up. So here, maximum tension, let's just put all that information in here. So according to that order, just gonna do this. IV, okay. The first aspect, the maximum tension of the string, so you would say 100 newtons. You would say, wait, how would you write this? The maximum tension of the string, 100 newtons is the maximum. I should say it has high tension. Right, this is high tension, let me think. Wait, actually, it's 100 newtons. The other answer is 1,500 newtons. Okay, I think... Oh my dears, I'm so sorry. I did not notice that the 0.1 kilograms is an answer U. Oh dear, sorry. Sorry, we have to answer this again. Mistake, my mistake. This should be S/V instead. So there is a difference between them. They should not be the same model. This is 1,500 newtons, 200 kilograms for the density, and then, okay, V, single strand, and whatever strong. So we already know that it's supposed to be V, so it should be stable. So yes, it would be V instead of S regardless. But let's discuss the other things, like the maximum tension of the string. So I'm just gonna look at the answers and talk about it. So first, so it should have a low density frame, reduce the overall weight, portable, easy to install, because this should be placed on a table. I think they mentioned this today. Oh, it might not have been this question. It's okay. This is something that should be usually placed on like an office table, so it should not be too heavy. Now, why? Oh, this one. Okay. Why should it be high tension? To be able to support the weight of the metal and drag due to the oscillations. And why? We can put the answers in. We can honestly just follow that model. So, okay, follow it. High tension. High tension. Okay, then you have to give your reasonings. So this one, we can follow what they said in the answer schema, which was should have high tension in order to what was it? Okay. Oh, I'm going to punch something real quick. So, in order to maintain the... Oh, is it maintain? You can say maintain or support. They say support. So it should be support the weight. Support the weight of the metal bobs and the drag due to oscillation. Okay, the second point we have to write about the density. So this is a lower density frame. So low density frame. I'm just gonna write the other answers in. We have to talk about the mass. This is a heavy metal bob. Then we had to talk about the final thing, which was the string arrangement. So this was a string V arranged string arrangement. Oh, V-shaped. There you go, V-shaped. Okay, let's talk the answer, the reasoning. So for a low density frame, it's because it will be portable. Reduce the overall weight so that it is easier to carry. stall, you could say. So now the heavy metal bob, what can we say that? We want to have a higher maintain, okay, maintain high inertia, we can say like that. High or large inertia. This way the oscillation can be sustained for a long time, you can say for a longer period of time. Now final one, to maintain the V shape, so you want to maintain the stability of the metal bobs. So you can reduce. I don't think I will put in the answer reduce the tension of strings, because it feels almost redundant to say you want. It feels almost what do you call this? Something that is it's almost contradicting to say that you want high tension and then to reduce the tension. So I'm actually going to cut this answer out and just going to straight away say to keep the momentum in one direction. Hey, one direction mentioned. Okay, I'm sorry my answers might be a little messy, but today was just to discuss these questions. So we have some more left here, which is D. We have D, which these are calculation questions, so we can go through them really quickly. So let's burn through these questions, shall we? Let's grab your piece of paper. Alright. So, a trolley. Okay, I'm just gonna draw this out actually. Question 5. My pens, my entire table. 5D. Let's go. My camera's out focusing. Okay, 5D. A trolley with the mass of 2 kilograms. A trolley slides down a slope. This is a slope from rest. So it's at rest here. Then it goes down to the vertical height. Okay, vertical height, that means like that. Then the vertical height here from the ground is 2 meters. Okay, state the energy conversion that is experienced by the trolley. Whoa, is that even in our syllabus? Apparently it is. Cool, man, that's not even in our syllabus. Alright, first we can figure out, because we're going to do calculations. No, actually no, let's just do it straight away, shall we? What is the energy conversion? Well, over here, since it's at rest, we only have gravitational potential energy. But when it starts moving downwards here, it becomes kinetic energy. So we can just straight away say it. Gravitational potential energy is converted to kinetic energy. Okay, next, calculate the total energy of the trolley at the initial position. So energy, what kind of formula is this? Am I insane? Do I not know what formula this is? Is this even in our syllabus? Am I going crazy right now? Apparently they want to test me on things I learned quite a while ago. Okay, so they want the total energy, that is just the, what's this called again? The mass, the MGH. This is gravitational potential energy. It should be the formula to that. MGH is equivalent to the total energy. So okay, I'm gonna write it the other way. E the mass, which was 2 kilograms, 2 times the width. Okay, they gave us 10 Newton kilograms, -1, and then the height was 2 meters. So 2 times 20, we get 20. 20 times 2, we get 2. 2 times 20, we get 40. So there you go, 40. Then it's energy, so it should be in joules. Now over here, number 3. They said if the work done, okay, whoa, this is really testing you also do this. If you don't know, all of this, well, actually, all of this has been testing on, oddly enough, this is Form 3, Science. Questionable. Why would they test that in the physics exam? For no reason. Alright. Okay, if the work done against friction is 4 joules, what is the speed of the trolley when it reaches the ground? Okay, find out the total energy first. So you take 40 joule minus off the 4 joules here, you should get 37 joules. Then, okay, using that same for the mass gram, what the freak? Mass gravitational potential energy is equivalent to E. I've got it. It's equivalent to E, and we know that E has another formula. The total energy here, it could be mv squared divided by 2, or you could write as 1/2. Sorry, you could write as 1/2 times mv squared. So that would be, sorry, did I minus something wrong? 34. Sorry, I can't do simple maths apparently. -4. It would give us 6. Where did I get these 7 from? Okay, 36 joules is equivalent to mass, which is 2 times, okay, the velocity we don't know, divided by 2. Okay, if you are like not strong in maths, I'm just gonna do it simply. No, throw this over there. So 36 times by 2, that would be so you get 2. 6 times 2, you get 12. 12, 1 over here. 3 times 2, you get 6. So that will give you 72. Then you have 2v squared, so you have to divide it by 2 again. So you get back 36. Then you have v squared. You don't want square, so you square root it. It's gone now. You cannot see the answer. So v is 6. Yes, 6, because 6 squared is 36. 6 times 6 is 66. 6 times 6 is 36. So its velocity, the unit would be ms-1. And okay, that is it. That is the entire question 5. Thank you so much for witnessing whatever was going on here. Good night.